This is another important question because this involves graphs. Graphs are always very important and you should always know how to interpret graphs. This graphs question, there are many questions which can be solved very easily with graphs, and if you can interpret graphs properly, there will be questions in which you can solve in one line also, and using the equations you will take pages and pages to solve them. So it is always important to know how to interpret the graphs. So interpreting this graph, we have been given two bodies of equal mass are heated at a uniform rate under identical conditions. This is the graph for the two bodies for the temperature versus time and the change in temperature versus time. Therefore, we need to find out the ratio of specific heats of the two bodies and the ratio of latent heat of the two bodies. Now let us see what is the region of latent heat. Latent heat is used whenever there is state change and during the time there is no temperature change. Therefore, this is the region of usage of latent heat for a body 1 and this is the region for usage of latent heat of body 2. Since the mass of both bodies are equal to 1, therefore the amount of heat taken by and they are heated at uniform rate. Let P be the rate of supply of heat. P is equal to rate of supply of heat. Since they are heated at a uniform rate, therefore the amount of heat required for the conversion of this body, let this be body 1 and this be body 2, required for the conversion of this mass is equal to m into latent heat of 1. The amount of heat required for the second body is m into latent heat of 2. Now the time taken for this to convert will be equal to this heat upon the power. This one is m into L2 upon P. Therefore we know the times for each of the two bodies. Now we see the time above as m into L1 upon P upon m into L2 upon P. This will be equal to the time of first upon time of second. The time of first is 4 seconds upon the time of second is 2 units, 4 units and 2 units. This gives us to be 2. Therefore, L1 upon L2 is equal to 2. So you get the answer for the ratio of latent heat of the two bodies, that is equal to 2. Now for the second part, rather the first part, we have to analyze this region because this is the region for usage of specific heat. Now we know that Q is equal to ms into delta T. Therefore delta T, this Q can be written is the heat supplied, that is equal to P into T, that is power into time. Therefore delta T, this delta T is the, let me write this as T, this delta T is the rise in temperature. Therefore delta T is equal to P upon ms into T. Therefore the slope of delta T versus T graph comes out to be equal to P upon ms. Therefore for the first P upon ms1 upon P upon ms2 can be written to be equal to the slope of first upon the slope of second. Now the slope of first is equal to the tan of this angle, that is written to be this upon this, that is 60 upon 2 upon the slope of the second one, that is this upon this, that is equal to 40 upon 4, that is equal to 10. So in solving this we get S2 upon S1 is equal to 30 upon, that is equal to 3. Therefore S1 upon S2 is equal to 1 upon 3. Here S1 and S2 are the specific heats. So here C1 and C2 are written as specific heats, so it's the same thing. So we write this as C1 upon C2 is equal to 1 by 3 and L1 upon L2 is equal to 2. So we get the final answer for the ratio of the specific heats and the ratio of the latent heat of the two bodies. So we learned from this question as to how to interpret graphs properly.